Hi everyone, my name is Jesus Gomez and I'm gonna present my key activity stage 3. First we go with the introduction. So my research question is, does the amount of PSIs in a football affect the distance and hang time when it's kicked as a field goal? And I think this experiment is important because having a small difference in the air pressure of a football can affect a lot of game, not only in the kicking game but in the football game in general. So it's important to know in this case how the kickers are affected. And I was also curious about this because I'm a kicker, so I really wanted to know how my performance was affected in this situation. Next, we have the theoretical framework. So what happens on a field goal is that the kicker tries to put the ball through the uprights and over the crossbar. So in this type of play, a lot of factors are involved, such as humidity, wind, temperature, angle the ball is kicked, force, and air pressure. This last factor is the air pressure is the most important one, because having the ball at a good pressure means that when the kicker strikes the ball will compress correctly so the path of the football has power and direction. So to make this the previous statement clear, when a football is inflated, a lot of air enters it, so it makes the air inside of the football be squashed because there is less space for more air. So by having high pressure, the air can press better back the foot when it's kicked with the same force it was struck, and the ball will travel far ahead. Next, we have the methodology. So my hypothesis is if a leather ball with a circumference of 53 centimeters, a weight of 500 grams, and the shape of an oval was inserted with PSIs of 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and then kicked with the same force each and every time, then the ball with higher measurement of PSIs will travel farther than the other balls and with more speed, because with low PSIs there is more space and less air, so when the force is applied the air can't press back and generate the same force applied to it. Okay, next we have the variables. So the dependent variables are the distance and the velocity, because these two depend on the levels of PSI the ball has. Next, we have the independent variable, that is the measurement of PSI in the ball. Sorry. Next, the control variables are that the same force is applied to the kick every time, the temperature, the wind, and the ball starting point at the same spot every single time. Next, the materials. I used a Wilson 11005 leather football, an air pump, a pressure guard, a football holder, that is the stick that holds the football so that it can be kicked, and my phone to record the experiment. That we're gonna see the video in the next slide, I think. Okay, so the method I used is, first I'll get to the football field with the yards marked down. So I'm gonna need to change the yards to meters. Next I'm going to inflate the ball to 6 psi. Then the ball will be kicked and the data will be collected. The data that is going to be collected are the yards and seconds. And I'm gonna use the seconds to show the velocity of the ball as an extra data. And I'll repeat these steps till I inflate the ball to 15 psi's. So after concluding the experiment, the data collected will be presented in graphs so that it's more clear if the distance and velocity are affected by the PSIs. Okay, results. First, the conditions during the experiment were unexpected and not the best for the good of the results and development of it. There were very strong gusts of wind that affected the experiment, but I still think we got good results that can answer our hypothesis. And the wind was 13 to 31 kph. The temperature was 21 degrees Celsius, and the humidity was 36%. Here's the data collected. This chart I made in Excel so that it can be better expressed. And next, we have the video. Okay, so I'm gonna play it a few seconds so that you can see it. Here are the conditions. It says, because of the time issues, I'll only present one clip from the experiment, but this process was repeated for the 10 measurements taken. So there I'm inflating the ball, the football. Then I'm checking the pressure. I'm setting the ball with the sticks. I'm taking my steps. And I'm gonna kick it right now. Yeah. The ball is kicked, so I see where it landed. I write down where it landed, the distance. I go for the football and I repeat it till I get to 15 psi's. Okay, next. Conclusion. After analyzing the data, I have come to the conclusion that the PSIs doesn't affect the distance the ball travels and neither the hang time the kick has. The windy conditions have a more important effect on the path of the football and would have been better if the wind wasn't present during the experiment. Based on the evidence, I believe that the wind affects the path also by the direction it goes to and which panel of the ball hits. I'm gonna explain it. Okay, I have a football here. So I'm gonna try to explain it. So this is the football and this is the normal rotation of a football. So if let's say the wind is coming from, I have the wind at my back, so I'm taking the ball to my clothes, then I kick the ball and the rotation will be like this. Then the wind will hit this part of the football and will increase the distance and the hang time because it's pushing the ball through to where I want it to go. But if the wind is coming this way and I want to kick the ball that way, then I'm kicking into the wind and the ball will stop because the resistance of the wind is higher than is stronger than the force I applied to the kick, and the distance would be not as big as if I am kicking with the wind at my back, and the hang time will be also small. And yeah, so therefore the hypothesis I stated is incorrect. The experiment would have been better if it took place in a closed environment with no wind, and also if I have used another type of football, for example, as synthetic football. It's not common leather. It's synthetic, as it says, so it is heavier and it can change a lot the results. For the data collection, I saw that an app has recently been launched that helps measure distance, height, speed, and more stuff. So with that app, I would have made the experiment even more accurate as it is now. And thank you.